now we will move to another important problem. The problem is related to the factorization of polynomial. It is very common and popular question that has been asked in many times CSIR NET, and you will see the similar kind of question here. Obviously, this question is important that I said earlier. So what is the question? Fx equals to x square plus x plus 1, gx equals to x square plus x minus 2. Choose the correct statement. So here one thing is very common that we need to observe. So the value of g1, just put the value of gx at x equals to 1, g1 equals to 1 square plus 1 minus 2, 0. So that means if we take any field like zpx, or you can say z quotient pzx, this is a field because p is a prime here. So for any prime we can say gx is reducible because x minus 1 is a factor of gx in z px, or you can say or z quotient pz x, where p is a prime, So that means we can say this is a degree 2 polynomial. So here gx is our degree 2 polynomial, and we know if a polynomial is degree 2 or degree 3 and it has a root on a field f, so that polynomial must be reducible. So that means gx is reducible over zpx, or you can say z quotient pzx. So this option is false. Here it is given irreducible. Now we come to this problem. If it's irreducible over zpx for each prime, so now you will take, just to think about, if you take x equals to 1, 1 plus 1 plus 1, 3. So just you take in z3 or z quotient 3z. In that case, so here fx is like this. That means you take p equals to 3. In that case, what is your f1? Your f1 will be 1 plus 1, that is 3, and this is equals to 0 in z3x. Or you can say z quotient 3zx. So obviously, this is a root. Now we see the degree of fx, this is equals to 2, and f of 1 equals to 0 in z quotient 3z. So that means z quotient 3z, that means fx is reducible over z3x. So that means for here it is for p equals to 3. So for each prime, so if we take p equals to 3, this option is false. Again discard it. Now we come to next thing. G is irreducible over qx. We have seen gx has root. The g1 equals to 0 in qx. So obviously it has a root, that means we can factor it. So it is reducible. G is irreducible over qx. This is false. So we have strike out already 3 options. So you know in each question at least one option will be correct. So if it is irreducible over qx, that you can check with the help of Eisenstein criterion, or you can check it easily with a different method. You can check it easily. You know this recall over z2 you know x square plus x plus 1 is only irreducible polynomial, and from this you can conclude f is irreducible over qx. So that is the theorem. Or you can apply the Eisenstein criterion. You take f of x plus 1, and after that you apply the Eisenstein criterion, and then you can conclude again f is irreducible over qx. So these are the few important questions as well as important results that we always know, we need to know before attempting the CSIR NET exam.